we're going to be looking at the composition of inverse trig functions. The first thing that we want to do is use the properties of inverse functions to find the exact value of the expression. What we need to do is we need to remember what the inverse properties are. For the sine, we know that if x is between -1 and 1, then the property is that the sine of the arcsine of x is equal to the x. In our example, we see that point 9 is between -1 and 1, so the sine of the arcsine is going to be equal to point 9 via the definition. The sine of the arcsine of point 9 is equal to point 9. Let's remember what our definition for the arc cosine is. For the arc cosine, if we have x between -1 and 1, then we can define the cosine of the arc cosine of x to be x also. Here we see that point 3 is between -1 and 1, so we know that the cosine of the arc cosine of point 3 is equal to point 3 also. The last one we need to look at is the definition of our arctangent. For the composition of the arctangent, if x is a real number, then the tangent of the arctangent is equal to x. So we see here that -0.54 is a real number, so we can use the definition provided here. So the tangent of the arctangent of -5.4 is going to be equal to -5.4. For our next example, what we want to do is we want to use the properties of the inverse functions and the unit circle to find the exact value of the expression. So we want to find the arcsine of the sine of 5 pi over 4. The first thing we need to do is we need to find what the sine of 5 pi over 4 is. And we go to our unit circle, and we find that the sine of pi over 4 is going to be negative square root of 2 over 2. So it's right here. And then we want to find, well, what is the arcsine of negative square root of 2 over 2? Basically, what this is saying, the sine of what angle is going to be equal to negative square root of 2 over 2. Okay? So remember that the arcsine is defined in the first and fourth quadrant. So we're looking for an angle either here or here. In this case, we're going to be looking for an angle that's going to be in the fourth quadrant because it's negative. If we go over to the unit circle, we're going to see that it's going to correspond with 7 pi over 4. However, our 7 pi over 4 needs to be between negative pi over 2 and pi over 2. So we're going to just convert our 7 pi over 4 into, well, we know it's right here, so it's going to be equal to negative pi over 4. So in this case, the arcsine of the sine of 5 pi over 4 is going to be negative pi over 4. The next example we want to find is the arc cosine of sine of pi over 11, pi over 11 over 6. So what we want to do is we want to find what the sine of 11 pi over 6 is. We go to our unit circle, and it's right here. So that means that if we look at our y-coordinates, it's going to be negative 1/2 for the sine of 11 pi over 6. So we want to find the arc cosine of 1/2. Remember, that just means that we're finding the cosine of some angle is going to give us negative 1/2. The arc cosine is defined in quadrants 1 and quadrant 2. So we know that in the first quadrant, the cosine's all positive. So we know that the angle is going to be in this second quadrant. So if we go to the second quadrant, what we see is that the cosine of some angle is equal to negative 1/2 is going to equal 2 pi over 3. So what we have is the arc cosine of sine 11 pi over 6 is going to equal to 2 pi over 3. The next example, we want to find the cosine of the arcsine of negative 3 pi over 2, of square root of 3 over 2. The first thing we need to see is where our arc cosine is. Okay, our arc cosine is defined, we said, in the first and the fourth quadrants. we know that since it's negative, it won't be in the first quadrant, so it's an angle in the fourth quadrant. If we go and look, we want to see, well, what sine of what angle in the fourth quadrant is going to give us negative square root of 3 over 2. If we look here, we're going to see that's going to be 5 pi over 3. But remember the way the arc cosine is defined, that our angle has to be between negative pi over 2 and pi over 2. So we just need to convert this to a negative angle. So if we go this way, we're going to go negative pi over 3. So now what we want to see, well, what is the cosine of negative pi over 3? Okay, so we know that once again, negative pi over 3 is right here, and we know that the cosine value is our x value, so it's going to be positive 1/2. So finally, we have the cosine of the arc sine of negative square root of 3 over 2 is equal to 1/2. The last one what we want to look at is the arctangent of the tangent of 5 pi over 4. So we want to find what the tangent of 5 pi over 4 is. 5 pi over 4 is right here, and we know that the tangent is our opposite over adjacent, so this is just going to be a positive 1. So the arctangent of 1, because this right here is 1, and we want to see the tangent of what angle is going to give us to 1. But remember that the tangent is defined also in the first and the fourth quadrants. So our tangent's positive in the first quadrant. So we want to see what angle course gives us a value of 1. So when we look on our unit circle, we're going to see it's pi over 4. Okay, so then we have the arctangent of the tangent of 5 pi over 4 is going to be equal to pi over 4. The next thing what we want to do is we want to find the exact value of the given expressions. So what we want to do is we want to draw a right triangle and find all the information. Okay, so what we want to do is we know that the arc sine, so the sine of some angle is equal to 3 pi over 5. So the first thing that we want to do is we want to draw our triangle. Arc sine is defined in the first and the fourth. And since it's positive, we're going to draw a triangle here. Here's theta. The sine is our opposite over our hypotenuse. So this is 3, our hypotenuse is 5. And we want to find this other side down here. This is a Pythagorean triple, so it's going to be equal to 4. So now since we defined what our arc sine is, what we want to do is we want to find the secant of that angle. So the secant, we know, the secant of the angle is our hypotenuse over the adjacent. So the secant, we said, is 5, the adjacent is 4. So the secant of the arc sine of 3 over 5 is equal to 5 over 4. And in the next example, what we want to do is we want to find the cosecant of the arctangent of negative 12 over 5. Okay, the first thing that we want to do is we want to start by drawing our triangle. We know that the arctangent is defined in the first and the fourth. It's negative, so it's going to be in the fourth quadrant. So that's theta. And let's label it. The tangent is our opposite over adjacent. So we know that our adjacent is 5. Our opposite's going to be kind of negative 12 because the y's are negative. And then once again, this is a Pythagorean triple, or you could use a Pythagorean theorem to find that this side is 13 for our hypotenuse. Okay. So now we know what our theta is. It's defined to be with this triangle. So we want to find the cosecant of theta. Remember that the cosecant is our hypotenuse over our opposite. So our hypotenuse is 13 and our opposite side is going to be negative 12. So we put this all together. So the cosecant of the arctangent of negative 12 over 5 is going to be equal to 13 over negative 12, or negative 13/12. Okay. The last thing what we want to do is we want to write an equivalent algebraic expression for the composition of the functions that we have. So we want to sketch a right triangle just like we did in the last example. Okay, so we want to sketch the triangle for our arctangent. So this is, remember, our tangent, we said, is we want to find, well, the tangent of what angle is equal to x. I'm going to put it over 1 because the tangent is our opposite over our adjacent. Okay, it's positive, so it's in the first quadrant. Here's theta. And we know that we have x is our opposite side and 1 is our adjacent side. So what we need to do is we need to find the remaining side. So we're going to use the Pythagorean theorem and just call this y for now. So y squared is equal to x squared plus 1 squared. So y is equal to the square root of x squared plus 1. So this whole side is x squared plus 1. That's the hypotenuse. So now we define theta, and we want to find the sine of theta. Remember, sine, we said, is our opposite over our hypotenuse. So the opposite side is going to be x, and our hypotenuse is the square root of x squared plus 1. So the whole expression we have is the sine of the arctangent of x is equal to x over the square root of x squared plus 1. And then we want to do the same thing for the next problem that we're going to be looking at. For the next problem, we want to find the secant of the arcsine of x minus 1. Okay, so we want to see the sine of what angle is x minus 1. And I'm going to just put this over 1 because it's kind of a fraction. The sine, remember, is our opposite over our hypotenuse. Okay, this one doesn't have a sign. We're going to put it in the first quadrant. This is theta. Our opposite side is x minus 1, and our hypotenuse is 1. So our goal is we want to find what the remaining side here is by using the Pythagorean theorem. Let's go ahead and do that. So now that we found what the adjacent side was by using the Pythagorean theorem, we can find what the secant of the theta is. So secant of theta, we know that the secant is our hypotenuse over our adjacent. So if we look at our hypotenuse, it's 1, and the adjacent side is what we just found. So it's the square root of negative x squared plus 2x. So now we could put this all together. So the secant of the arcsine of x minus 1 is equal to 1 over the square root of negative x squared plus 2x.